Hello, this is a tutorial on calculation of the heat source in laser crystals using the software ASLD. When you click on the parameters of the module heat source, then you can see the heat source which ASLD is using. By default, it is relatively simple heat source model which is based on the Stokes shift, and it's mainly using this Stokes shift parameter, which depend on the ratio of the wavelengths of the pump light and the laser light, and an additional factor, since not all the pump light leads spatially to heat and to lasing, and therefore an additional increased power of pump heat source is needed. However, ASLD contains also two different models. One of them is used as soon as you describe your pump light by a spectrum. This is actually more interesting if you have, for example, a flashlight, and then you can describe that by a suitable file. But here, for reasons of simplicity, let us describe the spectrum by a Gaussian function, which we mainly have when we have a diode light. Now, what ASLD can do, it can take into account in detail the spectrum if two properties are satisfied. First of all, the absorption coefficient of the pump light must be given. Then not the default value of the absorption coefficient is used. And second, one has to switch on this option use custom frequency dependent pumping. So let us see what happens now, what kind of model is used in this case. Now after running ASLD, you can see that ASLD has used the following more complicated heat source model. You see that ASLD distinguishes pump frequencies with a wavelength smaller than the wavelengths of the laser light, and those larger than the wavelengths of the laser light. And this heat source model in particular is more important and more accurate when you have a flashlight. In case of a diode light, it will lead to a very similar result, and in both cases you need an additional factor increased pump power of heat source, because it's not exactly known which part of the light really leads exactly to heat and which leads to lasing. The third model which ASLD is using is a completely different model, and that model you can use when you click here on Use Extended Rate Equations, Calculate Heat Source, and here you can distinguish for heat for CV lasing or no heat for no lasing. So let us see what kind of model is used in this case. Now let us see what kind of model ASLD used now. You can see ASLD uses a more complicated model, which is based on the transitions which we have from rate equations, and in this case ASLD calculates the heat efficient coefficients. So this parameter, which was somehow an unknown parameter in the first two models, is now calculated by ASLD. Such a calculation can be done only if in the material module, as you can see here, in the rate equations, interionic processes are described. And then what ASLD is doing is, for each of these transitions, a certain amount of heat is generated, and you can describe which amount of heat is generated. For example, for this transition, 1%, 100% of the energy is going to heat, Here you see the related heat efficiency for this transition with respect to the total heat generation. Here also we have 100% heat generation, but here for this transition, for example, we assume that only 30% of the energy goes to heat. Maybe the other 70% go to radiation. Uh, Such parameters you can also get for a cross-relaxation here, and you again see the heat contribution for this transition. For all these calculations, it's important to assign for each level the corresponding energy, otherwise the heat generation cannot be calculated accurately. Yeah, thank you very much for listening to this tutorial.